Hey Trig class, this is day one of starting to record videos for online learning, so hopefully this goes well. I will tell you that you probably do need a calculator for the section that we're going to talk about today. We are going to jump right into 10.1, and what I will probably do, I'm going to go ahead and turn my screen on. What I will probably do is for this video and for kind of homework, I will start just embedding questions into this video. So we might do an example and then I'll kind of post a question, that's kind of along the same lines, and that's kind of what your homework will look like for this section. We'll try it, see if it works. Otherwise, I can do different ways of doing things. So we'll see how it goes to start with. But Section 10.1 is the law of cosines. You are going to be very happy with these first couple sections at least, because no more trig identities and stuff that you're trying to solve for. We're going kind of back to right triangle trig, even though these aren't right triangles, and going back to like main cosine, sine, that type of thing, okay? So this section is the law of cosines, and 10.2 we'll be doing the law of sines. But the important part for you to remember in section 10.1 and 10.2 that this is used for non-right triangles. Okay? So when you have a right triangle, like how do you solve for the sides? How do you solve for the angles? So for right triangles, you use SOHCAHTOA. Okay, but you cannot use SOHCAHTOA if it's not a right triangle. So what we do is we use either the law of cosines, or in the next section we're going to be talking about the law of sines. So these are used for non-right triangles. All right. So use law of cosines when dealing with three sides and one angle. Okay, that's really, really important. Three sides, one angle. Now, one of those things you will be solving for. So maybe you have all three sides and you're missing the angle, or you have two sides and an angle and you're missing the third side. Okay, so one of those things you're going to be solving for. And here's what you're doing. This is what the law of cosines formula will look like, and that's the one that you're going to be using the entire time. I don't like necessarily that they put the second and third equation because they're just the same thing but with variables switched around. So I'm going to cross those out. But the main thing that I want you to remember is that like the little letters are sides and the capital letters are going to be your angle. Okay, so there's going to be one capital letter just because there's one angle, right? Okay, and the capital letter or the angle that you're talking about has to be basically what your side is set equal to. So this angle has to be across from this side. So whatever side that you put here, this has to be the angle that you're talking about. Okay, so it has to kind of go in that order. Otherwise, B and C can kind of be switched around. It's kind of like when you're doing the Pythagorean theorem, how these two can switch around, but your C squared has to always be the same. That's kind of how that works. Okay. They went ahead and gave you another alternate form of cosine, which we'll talk about here in just a minute. But there's kind of that switched around. So basically, they've subtracted the b squared over, they've subtracted the c squared over, and then they've divided by negative bc, or negative 2bc, to get what this guy looks like. And then they have cosine of a kind of solved for it. So they've kind of isolated that. Okay. So what we're going to do in example 1, it says solve the triangle for ABC shown. Okay. And whenever it says solve the triangle, you're trying to solve for everything that's not already there. So we have an A, a B, a C, and then we have a lowercase a lowercase b, and a lowercase c. Okay, so that's what we're trying to solve for. I usually just write out all 6, even though we're given like a couple things already. So capital C I know is 110 degrees. Okay. Here we don't have a 90-degree angle, but we do know that that's 110, okay? And then it's like, okay, what is 10 and what is 16 associated with, okay? Now, always remember that the sides across from the angles have the same name. So if this is angle B, this is going to be side B, because 10 is across from that, okay? So we note that with a lowercase b. A is across from 16, so that, whoop, I don't know where I put C there. So that one's going to be a lowercase a. So I can label those. That's 16, and this guy is going to be 10. So there he is, right? All right, now we have 3 other things that we need to solve for. And, we can't use the Pythagorean theorem to solve those things. But what we can do is one of these identities up here. So, or one of these law of cosines or formulas and stuff here. So let's go ahead and let's solve for our third side quick. C is the one that we don't know. So I'm going to use the formula up top here, and technically we're kind of using the third one because that's what C is called, but it doesn't really matter what your A, B's, and C's are. So I just need to know that C needs to be in this first spot, okay? So I have C squared equals, and then from there it doesn't matter which one is B and which one is C. Those are just my other two sides, okay? So one of them is going to be 10 squared, plus C is going to be 16 squared, and then I have minus 2BC, okay? B and C were the sides that I had labeled here, B and C. So that's going to be 2 times 10 times 16, and then I have that times cosine of A. That's a lot of information. In this case, it's not cosine of A actually, it's actually 110, okay, because that's the order that we put them in. All right, so just look and make sure this is the side that you're looking for. This is the angle across from him. So even though they have it labeled as A up here, those are the two C's and they go together. Okay, now here's what people will do a lot. 10 squared, they'll write that out as 100, great. 16 squared I think is like 256, but they'll add those two together and they will go ahead and subtract, let's see, 2 times 10 is 20, times 16 is 320. They will go ahead and put those three things together. They'll say 100 plus 256 minus 320, and they'll write that all as one piece. Okay, now here's the problem though. Cosine of 110 is attached to the 320. Okay, so you can put these two together, but you cannot put that with it until you've multiplied by the cosine of 110. Okay, so we're going to enter that all into our calculator. I have a dumb calculator. This is the only one that I brought home. So you guys will have your probably scientific calculators or whatever you have that you're using. But go ahead and practice typing this in when I type it in. Now, here's the question. Are you supposed to be in radians or are you supposed to be in degrees? Okay. What I'm doing for cosine, this is the only trig function that I'm typing in, cosine of 110, that's 110 degrees. So you do need to be in degrees. Okay. So I'm going to type this all in. You can type it in pieces if you want to, but I'm going to type it in all at one shot. So here's what it will look like on my even dumb calculator. I have 100 plus 256. I think that's what 16 squared is, right? 16 squared, 56. Yeah, it's got to be. Minus 320 times cosine of 110. And I typed that all in one shot, and I got 465.44, or 465.45. Okay, so let's see how this works. 465.45. That's what C squared is. Okay, I want to take the square root of that now. So I need to take the square root, and I'm going to go back through and say the answer, and it will be 21.6, let's say. C is equal to 21.6. Okay, and that's what he will look like, 21.6. We'll go ahead and round to one decimal place for each one of these. Okay, give me a second, I'm going to plug my computer in before he decides to die completely on me. Let's see how this is going to work. Here we go. Okay. So there's what C squared is, or C is, okay? Now we have to solve for A and B, and it doesn't matter which one you solve for first. So let's just go ahead and do A first, okay? So here's A. Now, in this case, I'm going to use this alternate version because what I'm solving for is the angle, and I kind of want to have him kind of by himself on the one side of the equal sign. We'll talk about getting rid of cosine here in just a second, but right now I'm going to write out what cosine of A is. So I have cosine A equals. Okay, now I have my other two sides, which are, well, I have all three sides, I guess, 16, 10, and 21.6. So the one that I really want to pay attention to is if this is my angle A, then this has to be my side A that I'm talking about. Okay, so side A is the one that's opposite from angle A that I'm solving for, and that has to be 16. So this guy has to be 16 squared. Okay, the other two I can switch around, it doesn't really matter. So let's call b squared 10 squared, and let's call c squared 21.6 squared. Okay, and then we have 2 times b is 10 times c is 21.6. Okay, now keep in mind that they're not necessarily labeled as b and c here, or in the diagram. So maybe if we're solving for cosine of b instead, this would be b and this would be b. So those two can just be switched around. They might call them something different, and that's okay. All right, so what I'm going to do is I'm going to, let's see, we could enter that all into our calculator at one shot. Sure, why not? Let's try it. So I'm going to do parentheses. Let's see if I can do this all together. Parentheses, 10 squared. If you need to, please do this in pieces. If you can't handle, you know, and you don't trust your calculator, go ahead and do this in pieces. So I've got that top part typed in. 10 squared plus 21.6 squared minus 16 squared, and then I'm dividing that by 2 times 10 times 21.6. Okay, now I realize that we're using the rounded version of the decimal 21.6, but at this point it's just kind of unavoidable. We can't really do that. We can't really, you know, avoid it. So I have 0.7188 or 89. 0.7189 is what I got. Okay, so make sure you're doing this on your calculator and see if you get the same answer as what I did. But that's what I got for A, and that doesn't make any sense at all, right? Like, how can you have point something of a degree if that's what A is? Okay, now there's one more step to this that we have not done yet, which is that's cosine of A, right? Cosine of A is that value. So now, you might know this already, to get rid of a cosine, you do the inverse cosine, and he will cross off, okay? So now that I still have that in my calculator, what I'm going to do is I'm going to do second cosine of that answer, okay? We do inverse cosine of the answer, and I get 44.04, okay? I'm just going to round it to 44.0. How about that? 44.0 degrees is what he will be. Make sure your calculator is still in degrees. And then we could do the process over again for B, but I really don't want to do that. I just want to subtract from 180, right? 44.0, 110 and 44 is 154, and if I subtract that from 180, 154, that's like 26 degrees, I think. Something like that, okay? So 26 degrees. And then I have solved the rest of the triangle, okay? All right, we'll do one more example, and then we will, I'll stop this video and I'll save the backside for the next video, okay? So find the angles of triangle ABC shown below. What they want us to do here is same process again, except I don't know any of the angles. So I'm going to start by using this second equation and probably maybe use him twice to find two different angles, and then I can subtract and find the third one. So we're really just finding the angles A, B, and C, and I don't know any of them, okay? So we can decide which one we want to find first. Let's just go ahead and find A first, okay? So to find A first, we have cosine of A equals, okay? Doesn't really matter what B and C are, but I know that A squared has to be, think about which one of these, okay? A squared has to be 20, okay? Because it's across from A, okay? B squared can be 15, sure, let's do that. C can be 8.3, and then we have minus 20 squared, okay? On the bottom, we have 2 times B times C. B is going to be 15, C is going to be 8.3, okay? Again, that might not be what they're named up here, but that's what we're going to call them because of how they kind of appear in the formula, all right? Okay, so let's see if we can type this in. If you need to type this in pieces, go for it. Like 15 squared, if you want to write this all out. 225, I'll do this one kind of in pieces. 8.3 squared is 68.89, and 20 squared is 400. So my top number, 225, minus or plus, I can't type, 68.89, maybe I can't type, minus 400. So practice typing this in just like I am. And is that really a negative number? Yeah, negative 106.11. Okay, bottom number, 2 times 15 is 30, so I'm just going to type that in as 30 times 8.3, and we get 249. So negative 106.11 divided by 249 is negative 0.426, okay? And that doesn't make a whole lot of sense for A to be that, okay? But there's one step I haven't done yet. I have to do cosine of A is what that is. So then I do the inverse cosine to get him out of there. Let me go down so you can see. Inverse cosine, and I can just leave what's in my calculator already, but do second cosine of the answer, then I don't have to type it all in again, and it's really, really super accurate. A is going to be at 115.2 degrees. 115.2 degrees. Okay, all right. Let's do one more of these, and then we can just subtract from 180. So let's solve for, I don't know, B next. We'll go in order. Okay, so now in this case, we're doing cosine of B. All right, and then on the top, so my formula, looking at the formula for the angle, if B is here, then B has to be here also, right? These two have to be across from each other. So this A squared, in place of him, he's actually B, he has to be 15. So 15 squared will go here. Then it doesn't matter which one the other two are, so 20 squared plus 8.3 squared minus 15 squared. Okay, and then what we'll do is 2 times 20 times 8.3. Okay, this one I'm going to type in all at one shot just so you can see it. So I'm going to do parentheses on the top, 20 squared plus 8.3 squared minus 15 squared, close parentheses, divided by 2 times 20 times 8.3. Okay, that's what cosine of B is. 0.7346, whatever. Okay, now we have to do inverse. Okay, so I'm going to do inverse of the answer. Okay, you can do this all in your calculator too. You can use the answer and not have to retype everything. 42.7 degrees-ish. Okay, that's what B was, 42.7 degrees. Then I can just add those two together and subtract. And then I have everything done. So I'm going to add that to 115.2, and that is 157.9. I'm going to subtract that from 180, and then I can find what C is. Whoop. I don't know why I wrote another one. Okay, 180 minus 157.9, and I had 22.1 degrees. So I found all the angles. I had to do the formula twice and then find the third one just by subtracting. So there you go. I'm going to stop the video there, and we'll do the backside on whenever I post the next video.